Operating a large crane is a highly specialized skill that requires extensive training, a deep understanding of machinery, a meticulous approach to safety, and a firm grasp of operational procedures. Cranes are indispensable in various industries, particularly in construction, shipping, and manufacturing, where they are used to lift and move heavy loads that would be impossible to handle manually. The following guide provides a detailed overview of how to operate a large crane, covering all critical aspects of the process, from pre-operation checks to load handling, maneuvering, and shutdown procedures. 1. Understanding the crane. Before attempting to operate a large crane, it's essential to have a thorough understanding of the specific type of crane you'll be using. Cranes come in various forms, including tower cranes, mobile cranes, crawler cranes, and gantry cranes, each designed for different tasks and environments. For example, tower cranes are commonly used in high-rise construction, where their height and lifting capacity are critical. In contrast, mobile cranes offer flexibility and can be driven to different job sites. Each type of crane has its own set of controls, capabilities, and limitations. A deep understanding of the crane's specifications, such as its load capacity, boom length, and counterweight requirements, is crucial. Overloading a crane can lead to catastrophic failures, including tipping over or structural damage. Therefore, operators must be familiar with the crane's load charts, which provide detailed information on the maximum loads that can be lifted at various boom lengths and angles. Two, pre-operation inspection. Before starting any crane operation, a thorough pre-operation inspection is mandatory. This process involves checking the crane's physical condition, ensuring that all components are in good working order, and verifying that safety systems are functioning correctly. Key areas to inspect include the hoist, hook, cables, and hydraulic systems. Any signs of wear, damage, or malfunction must be addressed immediately to prevent accidents. The inspection also includes checking the crane's control systems. Operators should ensure that all control levers, buttons, and switches are functioning properly. It's also important to test the crane's alarms and safety devices, such as limit switches, anti-tube block devices, and load moment indicators. These systems are designed to prevent dangerous situations, such as overloading or overextending the boom, and must be in perfect working order before any lifting begins. In addition to the mechanical and control systems, the operator must inspect the crane's surroundings. This includes checking for any obstructions, such as power lines, buildings, or other equipment that could interfere with the crane's operation. The ground conditions must also be assessed to ensure that the crane can be safely positioned. Soft or uneven ground can lead to instability, increasing the risk of the crane tipping over. Three, setting up the crane. Once the pre-operation inspection is complete, the next step is setting up the crane. Proper setup is critical to ensuring safe and efficient operation. For mobile and crawler cranes, this involves positioning the crane on a stable surface and deploying the outriggers to provide additional stability. The outriggers must be fully extended and placed on solid ground or appropriate pads to distribute the crane's weight evenly. For tower cranes, setup involves erecting the crane and securing it to the ground or a building structure. This process requires careful planning and coordination, as any mistakes during erection can compromise the crane's stability. The tower crane's mast sections must be securely bolted together, and the crane must be properly anchored to withstand wind loads and other environmental forces. Once the crane is set up, the operator must verify that the crane is level. An unlevel crane can cause loads to swing unpredictably, increasing the risk of accidents. Most cranes are equipped with built-in leveling devices, but manual checks should also be performed to ensure accuracy. Four, understanding load charts and capacity. One of the most critical aspects of crane operation is understanding and adhering to load charts. Load charts provide detailed information about the crane's lifting capacity at various boom lengths, angles, and configurations. These charts are specific to each crane model and must be consulted before attempting any lift. The load capacity of a crane decreases as the boom extends and the angle of the lift changes. For example, a crane may be able to lift a heavier load with a shorter boom at a steep angle, but its capacity will decrease as the boom is extended and the angle becomes shallower. Operators must be aware of these limitations and never exceed the crane's rated capacity. In addition to the weight of the load, operators must consider other factors that can affect the crane's capacity. These include the weight of the rigging, the dynamic forces generated by moving loads, and environmental conditions such as wind. Wind, in particular, can have a significant impact on crane operation, especially with large loads or long booms. Operators must account for wind speed and direction when planning lifts, and they should avoid making lifts in high wind conditions. Five, rigging the load. Proper rigging is essential for safe crane operation. Rigging involves attaching the load to the crane's hook using slings, chains, or other rigging equipment. The rigging must be carefully planned and executed to ensure that the load is securely attached and balanced. Operators must select the appropriate rigging equipment based on the weight and shape of the load. Slings must be of the correct type and capacity, and they must be inspected for any signs of wear or damage before use. The load should be rigged in such a way that it is evenly balanced, with the center of gravity directly below the crane's hook. In addition to selecting the right rigging equipment, operators must also consider the load's lifting points. The lifting points must be strong enough to support the load without deformation or failure. If the load does not have designated lifting points, operators must determine the best attachment points based on the load's shape and structure. Before lifting the load, operators should perform a test lift to ensure that the rigging is secure and the load is balanced. The load should be lifted just a few inches off the ground and held in place while the operator checks for any signs of instability or shifting. If any issues are detected, the load should be lowered and the rigging should be adjusted as necessary. Six, lifting and moving the load. Once the load is securely rigged and the crane is set up, the operator can proceed with lifting the load. This process requires careful control and coordination to ensure that the load is lifted smoothly and safely. Before lifting the load, the operator must communicate with any ground personnel involved in the lift. Clear communication is essential to ensure that everyone is aware of the lift plan and can respond quickly to any changes or emergencies. Hand signals, radios, or other communication devices can be used to coordinate the lift. The operator should begin the lift slowly, gradually increasing the height of the load while monitoring the crane's stability and the load's behavior. Sudden or jerky movements should be avoided, as they can cause the load to swing or become unbalanced. The load should be lifted straight up to minimize lateral forces on the crane. Once the load is clear of the ground, the operator can begin moving it to the desired location. This process involves carefully maneuvering the crane's boom and rotating the crane's superstructure as needed. The operator must constantly monitor the load's position and the crane's stability, making adjustments as necessary to prevent accidents. If the load needs to be moved over obstacles or through tight spaces, the operator must plan the path carefully and ensure that there is enough clearance for the load to pass safely. Ground personnel should guide the load as needed to prevent collisions and ensure that the load remains stable. During the lift, the operator must be prepared to respond to any changes in conditions, such as shifts in the load, changes in wind speed, or obstacles in the load's path. The operator should be ready to stop the lift at any time if safety is compromised. Seven, placing the load. Placing the load in its final position requires precision, and control. The operator must carefully lower the load, ensuring that it remains stable and aligned with its intended location. Before placing the load, the operator should double-check the placement area to ensure that it is clear of obstacles and that the ground is stable enough to support the load. If the load is being placed on a structure, the operator must ensure that the structure is capable of supporting the load without damage. As the load is lowered, the operator should make small adjustments to the crane's position and boom angle to ensure that the load is placed exactly where it is needed. Ground personnel may assist by guiding the load into position using tag lines or other tools. Once the load is in place, the operator should slowly release tension on the rigging to allow the load to settle. The rigging should not be removed until the load is fully supported and stable. After the rigging is removed, the operator should move the crane away from the load, taking care to avoid any obstacles. Eight. Shutting down the crane. After the load has been placed and the lift is complete, the operator must shut down the crane properly. This process involves securing the crane, retracting the boom, and stowing any equipment used during the lift. For mobile and crawler cranes, the operator should retract the outriggers and ensure that the crane is ready to be moved to its next location. For tower cranes, the operator should secure the crane's boom and jib, ensuring that they are locked in place to prevent movement in high winds. The operator should also perform a post-operation inspection, checking the crane for any signs of damage or wear that may have occurred during the cranes stand as towering symbols of human ingenuity, representing both the physical and metaphorical elevation of society's capabilities. From ancient constructions, like the pyramids of Egypt, to the modern-day skyscrapers piercing the skylines of our cities, cranes have been instrumental in achieving feats that were once considered impossible. These machines, with their capacity to lift and transport massive loads, have not only transformed the landscape of construction, but have also become pivotal in sectors ranging from maritime logistics to advanced manufacturing. As the demands of industry have evolved, so too have cranes, advancing from rudimentary mechanical devices into sophisticated, high-tech machines that incorporate the latest in automation, artificial intelligence, and safety technologies. The catalytic power of cranes lies not just in their physical capabilities, but in their ability to push the boundaries of what is possible, driving innovation and enabling the creation of infrastructures that define modern civilization. At the heart of this transformation is the evolution of crane technology. The earliest cranes, powered by human or animal labor, were limited in scope and application, yet they laid the foundation for future advancements. The introduction of steam power in the 19th century marked a significant leap forward, allowing cranes to handle heavier loads and operate with greater efficiency. This was followed by the development of hydraulic systems, which provided even more power and precision, revolutionizing the construction industry. However, it is in the 21st century that crane technology has truly come into its own. With the integration of digital systems, automation, and real-time monitoring tools, modern cranes are now equipped with sensors and cameras that provide operators with a 360-degree view of their environment, ensuring precise movements and enhancing safety. These advancements have not only increased the capabilities of cranes, but have also expanded their role in various industries, from constructing massive offshore wind farms to assembling intricate components in aerospace manufacturing. The impact of cranes on the construction industry is perhaps the most visible and profound. In the context of urbanization and global population growth, the need for taller buildings, larger bridges, and more complex infrastructures has never been greater. Cranes are the linchpins of these projects, enabling the lifting and placement of steel beams, concrete panels, and other materials that form the backbone of modern architecture. Tower cranes, in particular, have become synonymous with the construction of skyscrapers, their long booms and towering masts, a familiar sight in cities worldwide. These cranes are capable of lifting loads of up to 20 tons or more, hoisting materials hundreds of feet into the air with remarkable precision. The use of such cranes has made it possible to build taller and more complex structures, transforming cityscapes and accommodating the growing urban population. But cranes are not limited to construction. Their catalytic impact extends to other industries as well. In maritime logistics, for example, container cranes are essential for loading and unloading cargo ships, facilitating global trade on an unprecedented scale. The efficiency of these cranes, capable of moving containers weighing up to 65 tons in a matter of minutes, is crucial for the smooth operation of ports and the global supply chain. Similarly, in the energy sector, cranes play a critical role in the installation and maintenance of wind turbines, oil rigs, and other large-scale energy infrastructures. The precision and lifting capacity of cranes are vital for these projects, where the slightest error can have significant consequences. The ability to safely and efficiently lift massive components into place, whether on land or at sea, has made cranes indispensable tools in the energy industry, contributing to the development of sustainable energy sources and the transition to a low-carbon economy. The advancements in crane technology have also had a profound impact on safety. Operating a crane is a complex and potentially dangerous task, requiring skilled operators who can navigate the challenges of lifting heavy loads while ensuring the safety of both personnel and equipment. Modern cranes are equipped with a range of safety features designed to minimize risks and prevent accidents. These include load moment indicators, which monitor the crane's load capacity and warn operators if they are approaching the maximum limit, as well as anti-collision systems that prevent cranes from coming into contact with other objects or structures. Additionally, the use of remote-controlled and autonomous cranes has reduced the need for operators to be physically present in hazardous environments, further enhancing safety. The integration of these technologies has not only made crane operations safer, but has also increased efficiency, allowing for more complex lifts to be completed with greater accuracy and speed. As we look to the future, the role of cranes in industry and infrastructure is set to expand even further. The ongoing development of smart cranes, which use artificial intelligence and machine learning to optimize performance, is poised to revolutionize crane operation. These cranes can analyze data in real time to make adjustments to their movements, improving efficiency and reducing the risk of human error. The use of drones and other technologies for remote monitoring and inspection is also becoming more common, allowing operators to assess the condition of cranes and their surroundings without putting themselves at risk. In addition, the rise of modular construction, where buildings are assembled from prefabricated components, is creating new opportunities for crane technology. Cranes will play a crucial role in lifting and positioning these modules, enabling the rapid construction of buildings and infrastructure in ways that were previously unimaginable. In conclusion, cranes are far more than just machines. They are catalysts for progress, enabling the construction of the world we live in today and laying the groundwork for the future. From their humble beginnings as simple mechanical devices to their current status as high-tech marvels, cranes have continuously pushed the boundaries of what is possible. Their impact on the construction industry, maritime logistics, energy, and other sectors is undeniable, and their role is only set to grow as technology continues to advance. The integration of digital systems, automation, and AI into crane operation is not just enhancing their capabilities, but is also making them safer and more efficient, paving the way for even more ambitious projects. As we continue to build taller, bigger, and more complex structures, cranes will remain at the forefront, lifting our world to new heights, both literally and figuratively. The catalytic power of cranes lies in their ability to transform ideas into reality, to move the immovable, and to make the impossible possible. In doing so, they are not just lifting loads, they are lifting the very fabric of human achievement,